Hi, today we'll be solving linear systems by changing both equations. Solve the linear system.
Okay, I think I'll take it from here. Um, so here we go. Today we've been on the topic of solving linear systems, and again, I'm going to remind you that we're saying that we believe that this might be possible. We know that this is true. That we have two lines here, and looking at these two lines, it looks like we might have, I don't know, maybe something like this, and I'm not sure I'm right at all. I haven't thought this out all the way. But what I think is that if this is the orange line and this is yellow, I think that possibly they meet somewhere. And remember, if they do meet, then their x and y values are the same at the same time, right? So we're looking for what we're looking for when we solve this is we're looking for the point x, y. Remember, the solution to a linear system is a point x, y. So that's what we're looking for here. And we talked earlier today about the fact that sometimes we'll use a substitution method, and sometimes we'll just change one equation. Sometimes we'll be forced to change both equations. So in this case, this is remember what we're looking for. We're looking for opposites. So I'm looking at this 7x, and I'm looking down here at these x's, and I'm thinking, gosh, wouldn't it be terrific if this was negative 7x's, because then when I added them, I get 0. But positive 7x and negative 5x are not opposites, are they? Now I move over and I'll check. Maybe I get lucky on the y's, and maybe I'll look here and I'll get negative 12y's here, and down here when I look I'll get positive 12y's, but I don't. So then the second thing I start doing is thinking, well, if I just change one of the equations, if I just multiply one equation, the whole thing by a number, will it give me the opposite? And as I look, there's nothing times 7 that equals positive 5, or vice versa, or here or here. So now what I'm doing is I'm looking at these things, and I'm saying, you know what, I could think about this. If I multiply this equation up here by positive 5, and I multiply this equation down here by positive 7, I'd have 35x is here and negative 35x is here, right? Which sounds pretty good, but when I look over, I realize, look, the least common multiple here is a smaller number. It's just 24. So what I'm going to do here, and think about why I might do this. After I write this out, pause the video for a second and see if you can figure out what's about to happen. This is what I'm going to do here. I'm going to multiply this equation by positive 2. The whole thing, remember, I have to multiply both sides of the equation, right? The multiplicative rule of equality is what we're using here. In the bottom equation, I'm going to multiply this whole thing by positive 3. After I finish this sentence, pause the video and ask yourself, do the multiplication, multiply all the way through here and then all the way through here, and see if you don't find an opposite. And that's what I'm hoping for. So pause the video, take a look, see if you can figure it out, and then turn the video back on, okay? Okay, welcome back. Sorry, I thought that was very, very funny. Maybe you can hear my kid calling me, so I'm going to have to put you on hold for a second. Okay, sorry about that. So we multiply this thing through, and we get 14x minus 24y, don't we? And hopefully when you did your math, you noticed that something really cool happened at the bottom there, but let me see if it works for me. And over here I get negative 44. Remember, the biggest mistake, the most common mistake made in algebra is that people do not distribute completely. So make sure you distribute completely. If you don't mind, I'm going to write this second equation in a different color just so we can contrast the two. So we have 3 times negative 5x is negative 15x, and I get that didn't help. We have positive 14 at the top here, and we have negative 15 at the bottom, and that didn't help. But what about this? 3 times positive 8y is positive 24y. And I'm just, can you see it? Here's negative 24y, positive 24y. See how these are the opposites that we got out of this whole deal. And remember, distribute completely, and 3 times 14 is 30, is 42. Is that right? If that's wrong, please keep it to yourselves. It's too early for me to be brave. So let's see what we get here. We get negative, we have 14 minus 14x's minus 15x's is negative x, isn't it? Here's the beauty of the matter. We eliminated this, so Gauss would be very proud of you right now. And we have negative 44 plus 42 is negative 2. Isn't that right? So we get negative x is negative 2. Just so you can see it, all I'm going to do here is I'm going to multiply both sides by negative 1. Right? Multiply each side by the same number. Why? Because I wasn't looking for negative x. I was looking for x. So x is equal to positive 2. So remember, the solution here is going to be a point xy, right? So we're looking for an xy, and it looks like our x value is 2. Looks like our x value is 2. That's my story. Right? So just pick one of the equations and plug this 2 back in. So I'm going to take this, see the 7x right here? I'm going to take this equation right here. Why? Seriously, because I feel like it. I'm going to take this one and I'm going to plug this x value back in. So instead of writing 7x, I'm going to write 7 times 2, excuse me, minus 12y is equal to negative 22. We get 14 minus 12y equals negative 22. Add negative 14 to both sides because we're solving for y now, right, is negative 14, and we get negative 12y equals negative 36. You guys still with me? If not, stop the video for a second. This is worth it. Oh my gosh, what happened there? Trying to keep your life exciting. Is it working? You're not blind. You're okay. Okay, dividing both sides by negative 12, right? Whoa, by negative 12. This side by negative 12. And we get y equals 3. So it looks like our two lines meet at the point 2, 3. So the solution to our system of equations is the point 2, 3. How would you check that? You did this on your own, but hello. Go back to the original equations. Go back to the original equations. That's it, A. Go back to the original equations. Plug in x equals 2 and y equals 3 and see if it works. I think that it does. Proud of you guys. Keep up the good work. Please, 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 please. This is worth it.